I'd like to say hi to all the grade 11 students out there that have watched my first two videos. And today we're going to start with the third video, and it will pick up from where we left off with moland. If you haven't seen the second video that dealt with my famous analogy moland, please watch that before watching this one. If you did watch that video and you drew the picture, pull it out and also have a calculator handy along with your periodic table. So as you can see, I redrew a scaled down version of moland, but I kept the sharks in place just because I wanted to reiterate that you cannot go from grams to atoms directly, and you cannot go from atoms to grams directly. We have to go through moland to get to mass land, and vice versa from mass land to moland before we can go to particle land. So that is a short version of video 2. What I have included in this picture that I didn't talk about in the second video is the mole triangle. And many of you remember using triangles back in grade 9. The density triangle, it comes to mind where you have mass on the top and density and volume on the bottom. In this case, you can see we have grams on the top and we have moles and molar mass on the bottom. And I'm going to talk about molar mass today for the most part. So this is what molar mass is. Its units are grams per mole, which makes sense. How many grams of a substance are in a mole of something? We talked about carbon before, if you recall, and we talked about sulfur before, as you recall. Well, I went into my shop and I found a few elements. Ironically, it's amazing what you can find in your own property in terms of chemistry. So this is copper here, which we know is an element, and if you have your table, you can look up the atomic weight of copper quite easily. So if we look at copper, the molar mass of copper would simply be 63.5 grams per mole. So our table is very well laid out. It allows us to easily look up an atomic weight of an element, and of course that's in use. We can convert that number easily into grams per mole because we can't weigh single atoms. Grams are much easier to weigh. So this would be copper. Another element that I found, aluminum. And of course, this is an aluminum roofing nail. I've done my share of roofing jobs, although the older I get, the less inclined I am to get on top of a roof these days. This is aluminum, it's lightweight, and of course, it's in group 3. You can look it up on the table, and you can see that its atomic weight is around 27. Let's keep things simple, okay? So here's aluminum. Remember, you can look it up, group 3 element. If I asked you to give me 1 mole of aluminum, then you would go and weigh 27 grams. Again, I'm rounding this number off for simplicity. So that makes a lot of sense. Now, what about compounds? Well, I just happen to have a little bit of drywall in my garage as well. And you may remember that I talked about drywall as being calcium sulfate. It's actually a dihydrate compound. Let's not worry about the waters in this. So I've got little hunks of drywall here. Any of you that have had the pleasure of working with it know that it's pretty fragile. It's a bit dusty, but nonetheless, we can use this and talk about compounds in terms of how we get their molar mass. And we have to remember our nomenclature. It's funny how that keeps coming back into our course. So here we go. This is calcium sulfate right here. And you may remember that calcium sulfate involves a group 2 element, right? Of course, calcium is an alkaline earth metal, and of course, we know that calcium is 2+ and sulfate is SO4 2-. So that is the formula for calcium sulfate. The question is, how do we determine the molar mass of calcium sulfate? Well, it's very easy. All you have to do is some mental math. If you need a calculator, go for it, but I argue you're all smart enough to add up some numbers in your head. Let's round them off again to make life easy. So if we look at calcium, the molar mass of calcium is 40. That's from your table. Sulfur we've already looked at in the first video. It is about 32. And of course there are 4 oxygen atoms in each calcium sulfate. So we're going to multiply 4 times 16. And if you do your math, you can see we have 72 plus 4 times 16 is 64. And simply enough, this is 136 grams per mole. So again, we can find the molar mass of an element very easily. We can find the molar mass of a compound very easily. The last compound that I want to talk about is probably one of the most important, and that's water. So I've got water here in my graduated cylinder. Looks like about 360 milliliters of water. For now, it doesn't really matter. We're going to figure out in the next video how many moles are in this. But for now, we know that water, of course, its molar mass is easy to get because it's good old H2O, right? And the molar mass, of course, of water, very famous number, would be 2 times 1 for the hydrogen and 16 for the oxygen, gives us 18 grams per mole. What does that tell us? Well, if I ask you to go weigh 1 mole of water, you're going to weigh 18 grams of water. That's what molar mass is. More realistically, because water has a density of 1 gram per mil, we know that 1 mole of water is 18 mils of water. So we can actually fathom what that would look like. 18 mils is a much smaller volume than what I've got here. So I hope that this brief little video gave you some insights into calculating molar masses of fairly simple compounds. We'll revisit Mole Land next time, and we'll start looking at molar masses and use those numbers along with masses and moles to figure out particles and to go back and forth. Until then, we'll see you next time.